So I think this one we can, yes. All right, so I'm not yet late. We are now beginning with, we will still capture the finding the domain of a function. All right, so what will be your domain for number 1? So it seems that if it is a rational function, you should have a union, okay? So we're saying your x should not be equal to? You don't want the denominator to be 0.
Yeah.
So what value will make the denominator 0? What value will you substitute to x that it will become 0?
1/2.
All right. Yeah. So you would say 2x minus 1 should not be equal to 0. Okay. That's actually the idea there. So that you now have x should not be equal to 1/2. All right. So any real number will be acceptable except for x equal to 1/2. X should not be equal to 1/2. So how would you write that in interval notation?
Negative infinity.
All right. Negative infinity.
Half, but not including it.
Half, not included. So you put a bracket. Then you say union. Okay? So always remember that. That's for, if it's a fraction. You put union. And then again, it is a parenthesis. 1/2 to positive infinity. Okay.
Mm.
All right. So just remember that in whenever you have a fraction, then you look at the denominator, look for the value that will make the denominator 0, and that will be your restriction, and you put a union as your final answer for the interval notation. And use, of course, parenthesis. Okay, number 2. So for the square root sign, you would say the domain should be that the one under the square root should be greater than or equal to 0. Because if it's less, then it will not be a real number anymore.
2x greater than or equal to 0.
So the first step, you would say 5 plus 2x should be greater than or equal to 0. And then solve for x.
X should be greater than or equal to 5/2.
Negative, yes. 5/2, right? So putting that in interval notation, I mentioned that if it is greater, you always begin with that number and then you end with positive infinity. If it is less, you begin with the negative infinity and end with the number that you have there in your value of your x. So, because it's greater than or equal to, then we now have, right? So minus 5/2 and positive infinity. Okay. So in our discussion here, we would really just be very much concerned with fractions. So we call it rational functions, which we will be talking more on later on. And then the radical functions, where you have now the square root sign. So for fractions, the denominator should not be 0. For square roots, the value should never be negative. Okay. All right. So as I mentioned, we already talked about lines previously. Okay. So, and we have learned also about the slope intercept form of the equation of a line, which we now call, which is y is equal to mx plus b. Okay, we have learned this previously that I highlighted. Okay. And then we talked about the slope as the rate of change. And we talk about the B to be the y-intercept, which is, okay, the one where your line crosses the y-axis. And of course, we also learned about the x-intercept, where the line crosses the x-axis. So whenever we talk about linear functions, it's the very practical application of this is talking about rate of change. And we said that the slope is the rate of change. So whenever we're dealing with some relationships, especially proportions, we're using linear function. So just a reminder and maybe an application of slope or rate of change, then we'll just talk about that. Okay, so now, so the real world application of slope, or we call it rate of change, is now instead of saying y2 minus y1 over x2 minus x1, we'll change that into function notation. Because we said that y, you remember in our discussion, we learned that y is equal to f of x. Okay? So y is equal to f of x, and therefore, okay, all right. Let me put my pen. So we say y is equal to f of x. So previously, we would say to get the slope. This was a slope previously. We said m. So the symbol is delta. Delta y over delta x. Previously, we would have our m to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we're changing that into a function notation such that instead of y sub 2, it will now be f of x sub 2. Okay? And instead of y sub 1, we say f of x sub 1 over x sub 2 minus x sub 1. So that's the symbol that we will be using now in order for us to find the rate of change, or we say slope. So maybe just a little example of our rate of change in the real world. And you know that you, particularly all here, we are driving. It's very important that we need that we use gasoline. And wow, the change of prices in gasoline had really been very, maybe I'm not sure, maybe it's much cheaper somewhere in Texas or in Arizona, as far as we're concerned. But here in California, we learn it's just too much. Actually, yeah, in 2023, it went up to in some gasoline stations, it's close to $6. So I'm now just talking about average price of gasoline. Where in 2019 it was 3.67 the average, and then it went down to 3.13 on the average in 2020. But then it went high 2021, 2022 particularly, and then 2023 now it's going back again. We have already $5 or more for our gasoline. So now the question is, if we say that gasoline costs have experienced wild fluctuations over the last several decades, as you see in the graph that I am showing you there. So we want to find the average rate of change in the price of gasoline, where I am giving you the year and I'm giving you the cost. All right. In other words, that's why there is not the value of y in terms of the independent variable. It was just written y because it's the year. All right. So actually, the y here is our input. Okay. And of course, our c here is our output. So when I say c of y, that is a cost per year. That is the same as f of x sub 1 or f of x sub 2. And of course, the year there would be now your input. So maybe this is supposed to be our x, and this is supposed to be our f of x. But we are just putting it as y to symbolize year, and c to symbolize the cost. So we said that our change of y over change of x is of course your f of x sub 1, x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So it's already input and outputs that are given there, because this is the real world problem. So we're now talking between 2019 and 2023. So when I say f of x sub 2, the question is, what's the cost of gasoline in 2019? And the cost of gasoline is, so I would say C, just for putting in the symbol, CY2 minus CY1 minus your year 2 minus year 1. Okay. So the cost of gasoline in so we begin with 2023. That is so this is now our sub 2. Okay, this one. And then this is our sub 1. So in 2023, the cost of gasoline is 4.88. In 2019, it's 3.67 divided by the year 2 is 2023 minus 2019, which is of course the total number of years of our range from 2019 to 2023. So yeah, it's important that we have the calculator here. So 4.88 minus 3.67 is how much? Where's my calculator? Sometimes I also don't want to. Yeah, with calculator, you just use calculator. All right, so 4.88 minus 3.67 equals, divide that by, of course, 2023, 2019. That will be about 4-year difference. Answer? 4.88 minus 3.67, you have 1.21, and we divide that by 4. So what's the average rate of change in the price of gasoline? What's your answer?
0.3025.
0.3.
025.
All right. I erased it. Okay, 0.30. So that's about 30 rate of change. Is about within that period is about 30 cents. Okay, 0.3025. Okay. So the average rate of change between 2019 to 2023, that's about per year, is about 30 cents. Right, so that's one example. Let's have this. Okay, there's also rate of change, of course, in the distance depending on your speed. So it says, after picking up a friend who lives 10 miles away and living on a trip, Anna records her distance from home over time. So we want to know the average speed over the first 6 hours. And I think, that the speed is your distance over time, right? So speed is distance over time. So distance over time is actually a rate of change, which is, we talk about, it's like a slope, all right? It's a rate of change. So distance over time. Okay, so with that, will you please see the average speed over the first 6 hours? That's actually from 0 to 6. That's the first 6 hours. So of course, our output is the distance and our input would be the time, because it now depends upon the speed. So I'll just put so say distance t sub 2 minus distance t sub 1 over t sub 2 minus t sub 1. So that will now be your formula. So there we don't have the function in what do I say? It's already the outputs that are given and not the function in terms of an algebraic expression. Sorry. Okay. So distance T sub 2 is how much? So this is
290.
from 0 to 6. That's first 6 hours, okay? So it's 200.
92.
Okay, minus. On that
10.
first hour is 10 divided by, of course, 6 minus 0. It's just first 6 hours. So it's now 6 minus 0. So it will now 282 divided by 6. And what's the average? It's now the average speed over the first 6 hours. You know that speed would change. But we're now talking about the average change of the average speed. So 282 divided by 6. What's your answer?
7.
47.
7.
All right. So if it is now miles per, we'll put it as miles per hour. So the average speed over the first 6 hours is 47 miles per hour. So I just want to show some real examples of your slope or your rate of change. Okay, so with that, yeah. So now, just like our algebraic expressions, we can combine using addition, subtraction, multiplication, division, and now we will introduce a new way of combining these expressions now. Where I will now be very specific that we're dealing with functions. So we have the symbols given there. If I say the sum, it means that I am adding um, the sum of two functions. I am adding f of x and g of x. And our symbol is f plus g of x. And if you see f plus g of x, it means f of x plus g of x. All right. And if I say f minus g of x, then that means you are subtracting f of x minus g of x. F, we use asterisk for multiplication. And so when you see the asterisk, it means that you are multiplying f of x times g of x. If you see the symbol, this one, okay? It's over f over g of x. That means you're dividing f of x over g of x. And then a new notation that we will be learning here, we call it fog of x. It is now, composite. We compose functions, fog of x, which means that instead of x in your f, you substitute the function g of x. If I have g o f of x, instead of x in your g, we substitute the value of f of x. So we'll be learning how to do these composite functions as something new in relation to what we have already discussed before. So, well, I am just giving these examples, simple ones, where when I say f of x is equal to 4x minus 5, g of x is equal to 2x, then adding, you just say 4x minus 5 plus 2x, then you get 6x minus 5. So we have done this before. Subtracting, if I have f minus g of x, I mean I'm subtracting 4x minus 5 minus 2x. And so 4x minus 5 minus 2x, you get 2x minus 5. Multiplying f asterisk g of x. So it's now f of x times g of x. So 4x minus 5 times 2x, then you get 8x squared minus 10x. And then division, of course, that means that you're dividing f of x divided by g of x. So 4x minus 5 divided by 2x. And I think we cannot simplify that one anymore. That's already the final value of the function. So this one is just new symbols, but it's something that we have already done previously on algebraic expressions. Right. Now, for the composite function, it says that the composite function, you create one function by substituting that one function to another function. So that if I have f of x, 3x is equal to 3x plus 2. And then I have g of x, x plus 5. So this tells you that if I say f of g of x, instead of the x in your f, all right, we substitute x plus 5. So in the 3x plus 2, instead of x, I will put x plus 5. So 3 times x plus 5 is your g of x plus 2 because our function is 3x plus 2. So simplifying, you now have 3x plus 15 plus 2, and your composite function f of g of x will now be 3x plus 17. Okay. So that's it. So now when I say g of f of x, you now go to your g of x. And instead of x in your g of x, you substitute the function 3x plus 2. So therefore, g of, this becomes now g of 3x plus 2. So which means that instead of x, I substitute 3x plus 2 plus 5 gives you 3x plus 7. So f of g of x, instead of x in f of x, we substitute g of x. If we have g of f of x, instead of x in g of x, you substitute the f of x. So we call it composite functions. Okay. All right. So let's have a few exercise here. Okay. So we'll practice addition, subtraction, multiplication, division, and composite functions. All right, do this value numbers and then we'll discuss after you have done it. Okay, maybe number 1, that's easy. We can do mental math.
Plus G.
All right, number 1. That's easy.
X squared
X squared.
plus X plus 2.
Very good. Okay. That's easy. Mental, we'll just do mental. Okay, this one.
It's X squared
Mm-hmm.
is X plus 2.
Minus x plus 2 or minus x minus 2?
X minus 2.
Okay, it's minus 2 because you are subtracting minus of x plus 2. Okay, good. How about number 3?
X squared times X plus 2.
Therefore, what's your final answer?
X cubed plus 2x squared.
Squared, yes. So you multiply x squared times x squared times 2. Good. Oh, dividing.
X squared over X plus
That's
2.
easy. All right, x squared over x plus 2. Okay, so no problem with our addition, subtraction, multiplication, division. Let's do composite.
X
Oh,
squared.
or maybe you can write it down first. All right, yeah. Okay, we can put the symbol. So it means that your f o g of x will be now f of g of x. So it is now f of x plus 2.
Yes.
Such that instead of x here, you substitute x plus 2. Okay?
To be X plus 2 squared.
Yes. So therefore, it will now be x plus 2 squared. Simplify. So we'll have to remember what we have discussed previously. So squaring, what will be your answer?
Squared plus 4x plus 4.
Very good. Okay, yes. So let's now move to the other one. G O F of x. It is
will
now
be
G of F of x. So what will it be?
X squared.
Okay, so instead of x in this x plus 2, you substitute x squared. So that's easy. All right, so it will now be x squared plus 2.
2.
Very good. So I think that one is Simple, yeah? Right. Looks like we're dealing with some simple stuff here now. Okay, so that's how it is. All right. So anyway, more practice will be done when I give you some homework later on. Okay, now. So question, I mean, just for okay, just to understand what is this composition of functions? How is it applicable in the real world? Okay, let's see. Rachel, will you please read this?
You use composite functions whenever you buy a sell discounted item. When you are standing in the store trying to decide if you can afford the item, the first thing you calculate is the discount. For example, I want to buy this $20 shirt and it is on sale at 15% off. This means that the shirt is really $17. Now you must calculate what the shirt will cost after sales tax. Let's say it's 80%. 8%. 8%. Your total the shirt after the discount and sales tax will be 1836. This process of computation can be expressed as a composite function. If X equals the price of the shirt after the discount at GX equals the price after sales tax, then the function of the final cost of the shirt will be GFX.
G of f of x. All right. In other words, there are two things that you are doing here. You're thinking of how much is the discount and how much is the sales tax. So when you put them together, that becomes a composite function. So I just want to give an example of what composite function is. So you're saying you are now getting you are computing the sales tax from the value after you have computed after subtracting the discount. Okay, so that's actually the idea. All right, this one is the price of the shirt. You so compute the discount. All right, and then you now get the sales tax out of the discounted price. So it means that uh, computing the sales tax out of the discounted price is an example of composite function. So I just want to give an example that this one is really applicable in the real world. Okay, so let's have this one now. Manish, you are quiet. Please read. Where are you, Manish?
Okay, I read this. The function CS gives the number of calories burned completing S sit-ups, and S bracket T gives the number of sit-ups a person can complete in T minutes. Interpret C bracket S bracket 3.
Okay, we call it C of S of 3. Okay, that's the way to read it. C of S of 3. Okay, go ahead.
The inside expression in the composition is S of 3 because the input to the S function is time. T equals 3 represents 3 minutes, and S of 3 is the number of sit-ups completed in 3 minutes. Using S of 3 as the input to the function C of S gives us the number of calories burned during the number of sit-ups that can be completed in 3 minutes, or simply the number of calories burned in 3 minutes by doing sit-ups.
Okay, so this is another example of a composite function. You're talking about a function, and then you ask yourself, how many calories will I burn when I complete a certain number of sit-ups? Okay, and then your S of T is the number of sit-ups in a certain number of minutes. So when you want to know the number of calories burned after completing a certain number of sit-ups at a certain time, then that means that is a composite function. Okay. So these are just some examples so that you would know that, yeah, a composite function is not a very abstract thing that can be applied in your what do I say? That can be applied in daily situation. If you're in the area of health, or you are, in daily what's that? In our daily experience, like me, I always want to buy some discounted items, and I think everyone does that. Yes. So when we do two computations, all right, and we put them together, then that would mean composite function. Okay, so we will be talking more about functions, and of course, yeah, really, we just have just 3 more weeks or so, and we're ending our class. So I just want to remind you of your writing assignment. Oh, yeah, your application of I think I said algebra, but you can be very very more
You said not
general by saying application of math if ever it's not really very specific algebra that you have looked for. And so I think I mentioned that there will be a what's that, an advantage or additional points if you interview some people, and that must be reported that you have done some interviews, okay, on maybe the people in health, people in education. Ask them, how are you applying math, all right, in not especially for the interview. Don't be very specific with algebra because they might not be able to remember their algebra. So just say what are those, and that should that should be part of your report, huh? Because that must be submitted just before March 8th, before the final exam. So, or March 7, I should say. So, just a reminder. And so, I think that will be all for today. I will not give you as homework yet. Homework will come after our class next meeting on Thursday. Okay, so have a great day.
Thank you. You too.
Okay, you are most welcome. Let me now stop our